Hello everybody, welcome back to another video of me trying to learn Zig programming language with the goal of learning and getting into systems programming. In the previous video, we were doing the Ziglings exercise and we completed the exercise pertaining to errors, switch statements, the unreachable keyword, which was something new for me personally. We looked at the if else ladder and how it can be used with errors, and it was a fun exercise. Let's jump in to the next exercises, which is enums, enumerations. Perfect. Without wasting much time, let's dive right into it. Cool. Remember that little mathematical virtual machine we made using the unreachable statement? Well, there were two problems with the way we were using opcodes. And I believe with the mathematical virtual machine, they're talking about this. Yeah, pretty much. We had a bunch of operations and we had an unreachable keyword for else. This was also very interesting, a fun if-else syntax to extract the value and error separately if it's an error union. Cool. And in the enumeration, what are we learning now? Well, there were two problems with the way we were using opcodes. Having to remember opcodes by number is no good. We had to use unreachable because Zig had no other way of knowing how many valid opcodes they are. Yes, that makes sense. An enum is a Zig construct that lets you give names to numeric values and store them in a set. They look a lot like error sets. Yep, that's right. An enumeration are numerical values that are given an identifier name, essentially. So we have const fruit, which is of type enum, and these are the possible values of fruit. Yep, in situations like this, it's easier to skip the unreachable keyword. Perfect, and we can assign to a constant the value apple, and it needs to be assigned in conjunction with its type, which is the fruit type. Perfect, very similar to most languages. Let's use enum in place of numbers we were using in the previous version. Nice. We have the standard library, we have enumeration, we have ops. I believe it's increment and decrement, right? Increment, power, decrement. I only see these here, so I'll just write those. Increment, power, decrement. Perfect. Now we'll go here and say, let me actually look at the fun program we previously made to see if we can match that. Yeah, I think we got it right. Cool. Now we have a list of this values of the type ops enum, and then we have a current value, and we're saying depending on the operation, we can switch the path and say one of these things should happen. In this case, no else is needed. Why is that? It's not needed because the compiler sees this type and says, what are the possible values of the type? Is increment, power, and decrement. And we're switching on a particular type. We want to satisfy all possible values of the type. And in this particular instance, we are satisfying increment, decrement, as well as power. So there is no need for an else because there is nothing else. Very poetic, but perfect. That kind of makes sense. And we have debug.print. Let's go ahead and run this. I didn't run it before we fixed it because it would have just been a syntax error. Perfect. Nice, that works. So we can see we're starting off with 0. We incremented it to 1, incremented again 2 and 3 and 3 to itself, the power of itself. No, 3 into 3 again is 9. And then we again decrement to 8 and we decrement to 7. Perfect. The output is correct and we have solved the program while learning about enums. Fun. Let's jump on to the next exercise. Cool. Enums are really just a set of numbers. You can leave the numbering up to the compiler or you can assign them explicitly. You can even specify the numeric type used. Okay. That's interesting. I didn't know that. So we have const stuff, which is an enum, and then we'll say this particular enum has one value foo, and we're explicitly assigned it 16. And I'm assuming if we don't explicitly assign it, it'll start from 0. Generally, that's the convention. Let's see, you can get the integer out with a built-in function called int from enum. Okay, that makes sense. We'll learn about built-in properties in a later exercise. Cool, we'll trust the process and not jump ahead too early. And we are assigning to the constant my stuff, and we'll say add int from enum stuff.foo. Perfect. And the value will be extracted, and this will be assigned the unsigned integer of 8 bits, which is equivalent to 16. Perfect. Note that the built-in function starts with and, just like the import. Ah, okay, interesting observation. Yeah, I believe I had a similar question, but never explored it. When we did those comparisons, and I think we also had a splat operator that repeated a value. Yep, I remember that. Cool, let's look into the program. We have our standard import, and it says Zig lets us write integers in hexadecimal format. Okay, understandable. 0xf is the same value 15 in hexadecimal. Okay, understandable. Web browsers lets us specify colors using hexadecimal number, where each byte represents the brightness of a green, red, green, or blue component, where 2 hexadecimal digits are 1 byte. That makes sense. With a value range of 0 to 255. That's right. So each of these 2 hexadecimal digits stands for 1 byte. 1 byte is 8 bits. So each of these is 4 bits, I believe. Is that how it works? I guess so. Yep, together they're 1 byte. Okay. 8 bits. Please define and use a pure blue value color. Please define and use a pure blue value color. That's straightforward. Like, if pure blue is BB here, so I will say it's 0 x0000ff. Right? Perfect. And yeah, hexadecimal is the largest number will have a total of 16 numbers. So from 0 to 15, 15 being the largest value. So pure blue will be FF. That makes sense. So the main function, remember Zig's multi-line strings? Here they are again. Also check out this cool format string. Oh, okay. So we have X, and we're formatting it by saying 0 greater than 6. What does that mean? X is a lowercase hexadecimal separator. Okay, very straightforward. And then 0 is the padding character. The default is O space. Instead of space, we want 0. Okay. Alignment represents right aligned. Okay. In the output, it'll be towards the right. Okay, makes sense. And 6 width, use padding to force width. Okay. Interesting. Very. There are similar patterns across languages. Very common we see something like this for precision definitions as well and floating point numbers, but kind of makes sense. Please add this format into the blue value. Even better, experiment without it or try parts of it to see what prints. Perfect, that's exactly what we're going to do. First, we're going to fix this syntax error because we know it's just going to error out there. So we'll say color.blue. We're going to leave everything else the way it is in its format here. Let's just run this. And we'll see what is displayed, and then we'll work towards playing around with the formatting. Perfect. Now we're displaying, it's a multi-line string as well. Yes, the backslashes are multi-line, yep. So we're printing red, green, and blue, and we can see in red and green we are displaying it in this format 00FF00. Is it unsigned integer of 8 bits? 32 bits, okay. And we see in blue's case, hexadecimal representation is FF, right? Which is the max value for 1 byte, right? And when we say an unsigned integer of 8 bits, that's 1 byte. What's the max value of U8? That's 255. That's exactly what it is here with blue. Now we've wanted formatted in hexadecimal. First, I'm just going to put X, which should give us FF or some variant of it. Let's see. I don't think it'll give 0. 000 FF. No, I think it'll just give FF. Yep, it just gave FF. Now, since it can, okay. So we had, the width was 6 and the empty spaces was filled with 0. What I'm going to do now is I'm going to fill the empty spaces with Z, and I'm going to put the width as all 6 again. Let's see what happens. Perfect. All the empty spaces are now filled with Z. Now let's add 26 here. Perfect. All empty spaces are filled. Let's write it back to 6 so it meets the formatting. Let's run it. Cool. That was a lot of fun. We learned not only how enums work, but also a fun little tidbit on hexadecimals and formatting these hexadecimals in prints when we're printing something. That's a lot of fun. Something as well that I wanted to learn is building terminals and CLI tools. I feel like that would be a good starting point to systems programming, commandlets and stuff like that. And this is really important and fun to know. Yeah, that's a lot of fun. Cool. Actually, something else I want to try. It was right aligned here. What if I did left aligned? I'm assuming this is left aligned. What happens then? Does it look the same? Looks quite the same. Difference though, we see that this value, this is the actual value, and everything towards the right is the width, spaces. Okay, that was a fun little tidbit there. Very cool. Perfect. That was a fun exercise by Chris Bosch and team. Let's go to the next one. Structures. Yes, a very very exciting topic. For someone who's who's been so ingrained in object-oriented programming like myself, and that's primarily how we write business logic code at work. Classes are a huge portion of it, especially in a language like C Sharp or Java. Classes, one of the first things that I remember from a textbook is classes are blueprints for creating objects. And I believe structures are a value type, I believe. I'll be honest with C Sharp, I have not used structures all that much, except here or there when we're adding in a third party library. This is a use case for structure. Even sometimes the first party libraries do have structures. But yeah, very, very interesting. Let's take a look at it. Being able to group values together lets us return this. Let's just turn this, okay, independently defined variables. All of them can be logically grouped together. And the idea is point one, point two. There's a structure called point, and we're assigning X field in the point, X property to 3, Y and Z to their values respectively. We're doing the same thing for the second point. Now the point above is an example of a struct start for structure. Here's how the structure type could have been defined. Okay, I understand. Cool, we're saying point is a struct. I like this way in Zig where everything, even the type, is assigned as somewhat similar to TypeScript, but we explicitly use the type keyword, but pretty cool. And we're defining the struct, we're defining the name of the fields or properties, and we're giving it, specifying the data type. That way it works with initialization. This is pretty cool, the way we initialize .x. Cool. I don't know if Zig even has the concept of constructors or things like that. It is very much an object-oriented thing, so maybe not. Never mind. Let's move on. Let's store something fun with the structure, a role-playing character. Cool. We have the standard library imported. We have a fun structure. No, a fun enum, my bad. Because enum is just, it's similar to a list of values, but it's a name given to the integer value, which we could have assigned it to something. If we wanted to, we could have assigned it to integers, but in this case, I wonder if this would even have a value. I want to try write up a short example myself to see if it happens. Yeah, actually, you know what? I'm going to take a quick tangent. I'm very, very curious if this even has a value by default. I know in the second one, we explicitly defined it as, hey, this is going to contain unsigned integers as values. In this case, by default, I don't believe Zig will let that happen, but let's see. I'll say standard debug print, and we want to print unsigned integers, and we're going to declare initialize the anonymous type, array or tuple, whatever that is, tuple I believe, and we'll say ops.inc. Would this return 0? I don't know. Or with this error, I truly don't know. Let's try it out. That's the whole point of learning something new. I'll say zig run. Okay, it's breaking. Yep, it's saying you're trying to print U. Oh, my bad. U stands for Unicode. That's my bad. U stands for Unicode. S is for string. U is the Unicode representation for a character. My bad. How do we display numbers? We can look it up real quick in standard library, but just to run it by itself, maybe it will convert. No, it's actually printing the name when we directly print it. Okay, that makes perfect sense. What if I use the built-in function to convert it? What's the function again? Value from enum, int from enum. Is it going to error out or is it going to print 0? Let's see. It prints 0, so it starts with 0. Now let's try printing 1. And this is expected for those, if you don't know, I'll actually give a brief overview of why. Let's print in a tab space as well, maybe -t, yeah, it should work, it's pretty standard. And we have 2, that's right, style 0 based indexing, this is 0, this is 2. Perfect, yeah, for those, if you're somebody who's even watching this and you want to know how I knew that this would print the integer representation even though we didn't define, because enums are at a fundamental level just a name given to an integer, and the reason we do it instead of directly using integer is that we want to restrict the list of possible values, and that's useful in terms of when using within the switch statement or whatever. We want to give a name to the all possible values, and we want to underlying each of those names represent an integer value pretty much. So yeah, that was a fun aside. A little bit of a tangent, but I think in the interest of learning a language every now and then, while we trust Ziglings and the process of learning, and we don't want to jump way too much to the point where we're overly disorganized, we do want to take fun little asides every now and then to explore when curiosity peaks, because it's just fun to do so. Cool, let's look at exercise 37. We'll continue with that. We have a standard library imported. We have the enum role, list of possible values. Underlying enum starts with 0 based indexing by default, underlying integer values. Cool, and now we have a structure. Fun. And we have, please add a new property to the structure called health and make it an unsigned integer of 8 bits. Health, unsigned integer, 8 bits. Perfect. We have the main function, we have glorp device, and this is the name of the character. We're using the character struct, and we're assigning to each property inside the struct. Now, I do not know the technical term, if it's called a property or a field. In C#, there's a fine distinction between a property and a field. Properties are generally backed by a field, but I don't really know the technical term for it. Plus, I don't see Zig having getters and setters and all those programming construct which treats the whole program around data. It's a little different, not too far off. Cool, we have the struct, and now we're able to assign values and increment the struct too. Okay, perfect. I wonder if there's a way to restrict these things from happening and say, no, we're going to attach a method to the struct and we won't let you do anything else. I'm sure there's the concept of method. We have functions like this, and if something, a function inside a struct is essentially a method function that can only operate in the struct's scope, something like that. There will be something. We'll trust the process. Glorp device.gold plus equals to 5, so this would have been 25. We'll decrease health, which we just added here. Cool, but we never initialized it. What would be the default value? By default, if I did this to a variable, it would be undefined, right? Wonder what happens. I'm going to run this code and see what happens. Okay, we don't have to worry about what's the default value is, because immediately Zig's going to say, hey, what are you doing here? If you're going to initialize a struct, initialize every required property in that struct. Curious though, if there is a concept of nullability, I wonder if we just assign undefined to it. What happens in that case? Oh, we have this auto formatter in VS Code. Let me remove it. I need to change that. Let me quickly change that. Let me remove format on save for Zig. Cool. Let me just run this, see what happens when we assign it to undefined. Perfect. So it says this value does not exist. There is nothing here. Undefined does not behave the same way it does in Java. There's no truthy falsy things. It's just going to say this is undefined. You cannot perform operations on it. In fact, it's giving the exact reason as panic, integer overflow. What are you doing here? It's screaming. Okay, cool. We'll assign it to say 10. And let's run it. It should work perfectly fine now with 0 as health. Yep, we lost all our health, but we gained 25 gold. Poor choice of this unwise wizard to lose all his health for gold. But yeah, that was a lot of fun understanding structs. Let me see the time. We're at 27 minutes. I believe I want to keep it short at 30, but I believe we have it in us to do another exercise for struct. Such a fun concept. Yeah, I really want to do another one. Cool. Grouping values in struct is not merely convenient. It also allows us to treat the values as a single item when storing them, passing them to functions. Beautiful, beautiful point. Yeah, that makes a lot of sense. One of the reasons why we have the concept of encapsulation in object-oriented languages is this, and I would say struct to an extent solves that in non-object-oriented languages. But yeah, think about it in the previous example where we have, and again, I'm not trying to explain it by assuming somebody's understanding. It's more so to reiterate it for myself so I can grasp it. Take these list of values. Now we're saying initially that making it into a structure of points makes it well defined and logically sound. But the other natural advantage of this, of grouping, is passing along these values can now be logically passed as a single unit, and that's incredibly great. Cool, let's look into this further. Structs 2. This exercise demonstrates how we can store structs in an array and how doing so lets us print them using a loop. Perfect. We have the standard library imported. Same, we have the role enum with a list of possible values. We have the character struct, which is what we're interested in. And now we'll say there's an array of characters and that array is undefined. Perfect. Now we'll say characters of 0. We'll say, hey, there is a character where we've defined the list of value. Character, what about 1? Please add Zump loud with the following properties. Feel free to run this program without adding Zump. What does it do and why? This is interesting. Let's see what it does. Based on our previous run, I will say when we do this, one of two things might happen. One, Zig might print the first one, and on the second one, either print undefined everywhere or just fail and say, actually no, never mind. Since we're assigning it, it's just going to print the first one. That's it. Yeah, because we're starting from 0, and I believe the dot syntax Even though it hasn't been explicitly said in the exercises, it's pretty clear from here. Start from 0, go till the end. And we have each struct in the array of structs here, and then we have the num usize, I believe, is just the index, and usize is again the convention, not the word convention, it's the preferred type for indexes when we're using arrays. We learned about it previously. Let's just run this. I know this is going to work, and it's just going to show up that one particular struct. Yes, it works. Character 1, ooh, wait, I want to know how did character 2 come? I thought we only had one character. Interesting, it's not just printing 1, which makes sense because we have defined allocated memory for 2 possible structs. It is printing values, and like C, it's printing whatever garbage value it has. So in the second run, we'll print a different set of values. Why is it printing this exact value? Where is that being assigned? Let me run it one more time. It's still the same. Okay. I wonder what will happen if I run it on a different machine. This makes me all the more curious. I'm going to go on a slight tangent again. I'm going to say test.zig, and we'll import the standard function. We'll say function, public function, right? Public function main and we'll say of type void expressive sig, and let me say var a unsigned integer of 8 bits. Can I say it's undefined? And I'll say var b is an unsigned integer of 8 bits. Let me not put anything. Let me just print it. Standard library debug print and let me pass in the arguments. Oh, my bad. Run the wrong program. Zig run test.zig. Local variable is never mutated, so why is it a variable? Make it a constant. Understandable. It printed 64. Let me run it again. It's printing 64 again. I'm just going to rename it to B to trick the compiler into printing something else. It's still printing 64. Is there a reason for it? What if I print U32? Actually, what if I create another variable? We'll see C and we'll print both. Will both be 64? Is there a method to this madness? No, the second one's too. It all depends on whatever's in the memory location, I believe. Maybe that's what's happening. So we're able to access a memory space. Oh, now it turned into 1. Previously it was 2. Let me run it again. It turned into 1. Oh, it's the same set of values displaying. I'm going to do something even more nefarious that should not be done, and we'll say as long as it's true, run it. Actually, let's make it a little bit more reasonable. we'll say we'll start from I. We'll start it from 0. And we'll say, well, I is less than 1,000. Oh, we want to increment I. Let me see, we can do plus plus, can't we? Maybe I was wrong. Maybe I wrote that wrong. Integer overflow. That's right. How can an 8-bit integer have... Yeah, that's right. Change that to 16. Oh, my bad. Okay, it's been the same value. Let me remove C. Cool. It's just going to print whatever's available in that memory location, I guess. But I wonder how it knows the memory locations, whatever type we're calling, or is it putting a junk value? I believe we'll learn more about that as we go forward. But in this exercise, we can see that, hey, if something is not assigned, it's actually not going to blow up. It's just going to look at whatever is in the memory and give you a value. And that is not really a default value. And we cannot deterministically rely upon such set value. Cool. Let's go ahead and complete the exercise. We'll set characters of 1, and we'll say character, and we'll say the role is bard. So it is role.bard dot goal. I like the dot syntax. Is it Rust like or Swift like? I know it's like something. We'll say health is 100 and experience is 20. Now it's going to print the both the values that we assigned to it. Oh, my bad. Has no member name. Oh, my bad. This needs to be a value. Good error. Easy catch. Perfect. Now we have the value printed. This was a very fun exercise. We got to look at enumerations, we got to look at structures, we got to look at some cool little formatting around hexadecimals. All in all, very, very fun set of exercises. Huge shout out to Chris Bosch and his team of open source contributors. They have done a fantastic job with these exercises. I'm at exercise 40. Have we reached 40? Almost there. We're 38 exercises in. Incredibly fun to do. It's not monotonous. And we're not just reading something and moving on. We're actually getting our hands dirty. I wouldn't even say getting our hands dirty. It's so much fun, honestly. Plus, it's even more fun that these are designed to be run on your local machine, and getting that feel for playing with the compiler is really, really fun. I know I don't really have a cool setup like Vim and NeoVim. Personally, I just like my IDEs. I've grown to love the debugger, but it's always good to know how to play with the compiler before jumping straight into the debugger. But yeah, that was really great, and if anybody's interested, please check out Ziglings, and a huge shout out to Chris Bosch for putting this together. Also, as usual, a huge thank you to all the smart folks at Zig building this wonderful language, and um, also going out there on YouTube and everywhere else communicating about Zig, getting folks like me interested and being welcoming and making it so smooth for us to get into the language and learn it and learn systems programming. And It's really great, especially interviews with Andrew, who's the creator. I believe, let me see if I can pull up the members of SIG. Yeah, Andrew Kelly. Really great interviews. I watched one of his interviews with JetBrains, and it was such a good interview that I immediately picked up learning SIG within like a day or two. So incredibly grateful for those smart people there, as well as everybody else like Chris Wash, another incredible person coming in and helping us learn the language. I'm going to end the video there. It's been really fun doing these exercises. I hope if anybody's watching, you all follow along as well. And a huge shout out if anybody's a web developer like me. We're all software engineers, but it would have been so high level with web dev, which is also fantastic concept, handling requests and responses at scale, incredibly fun. But this is also fun, low level systems programming. Anyway, I'll end the video there. Thank you all for watching. See you all in the next one. Bye.